So again, welcome. What are we going to learn about today? We're going to review, pick up where we left off. We are going to continue our discussion on methods, right? On user-defined methods. Here's what we looked at last class period, the sum of numbers, where we created our very own method, right? Are we excited? We wrote our own method, and it's outside of the main method, but inside of the class. And what's the name of this method? It's called sum of numbers. This particular method needed two integers in order to perform its task. If you see there, we need to provide it two integers in order for it to work. What do we know? Once this method executes, it's not going to return anything. It's just going to do something. Does everybody understand that? How did I know that? Because you see here the method, its return type is void. So that leads us into our new discussion for today. So let's pick up in our notes, if you would, please. Okay. All right, so let's add to our notes here. The fourth thing that we're going to talk about today, main idea, is that there are two types of methods that we can write. Okay, so user, and I'll say that, user defined. And I'm going to say that in the, not user defined, methods in general, because even predefined methods as well. These ideas, this applies to those. So it's for predefined methods or user-defined methods. There are two specific types of methods that we can write or that can be written, okay? The first one is what we just looked at. The first one is what we call the void method, okay? A void method. We looked at what we saw an example of that during our last discussion on where we wrote a method called sum of numbers. And the second type of method that we're going to learn about today is what we call value returning methods. Value returning methods. Okay. And so what exactly, let me remind you of what a void and all of these things. I just want to let you remind you all that the notes that I put together, okay, quite a bit of sweat equity here. And with these lecture notes, you can open those lecture notes and review the things that I've discussed. Okay, but I don't like going slide by slide, but they're there for your for you to use later. But yes, void, right? We talked about what a void method is, but let's look at a formal definition here. So these are methods that do not return a value. They do not return a value. So these methods simply perform one or more tasks or actions, okay? They just simply perform one or more tasks. So imagine, I like to use this analogy, so just bear with me. It may be kind of corny, but just bear with me. But imagine I'm the boss, right? I'm the boss. And I'm going to use you all because I can see your tiles and faces right in my little screen over here. So let's say that I'm the boss, you all of the workers here, and I need some task done. Okay, so let's use this analogy here of the program that we wrote last class period. Let's say that I'm the boss. In this example, so Maine is the boss, meaning I'm starting everything. Okay, is everybody? I have the baton in my hand. I'm starting that relay race. I'm the boss. Is everybody good with that? And if I need task done, I'm going to call you all. I'll call you in my office. Okay, say, hey, Hedda, I need you to go ahead and if you don't mind, here are two integers. I'm going to give those to you. Okay, Hedda, you good? I need you, and your role is, Hedda, is to calculate the sum of these two numbers. Do you hear me, Hedda? And I want you to print it. I'm not going to print it. Okay, you good? So I called you into my office. You now have control. I've given you what you needed, which was those two integers. And what are you going to do, Hedda? What are you going to do?
I'm going to add them together and print
Very good.
the sum.
And once you're done, what are you going to do?
Return it to you, or do I keep it?
I don't know anything that you just did. Okay, I just know all I did was just told you what to do with it. right? And I trust that you did your job. When you completed your job, then you give control back to me. You just give control. You don't give any values. Does everybody see that scenario? Okay, we're good. All right, so that is an example of a void method. Okay, a void method, but it's also kind of not only a void, but also an example of pass by value. Everybody hear what I just said? I passed values to Hedda so that Hedda can do what she needed to do because she needs that. According to the function definition here, Hedda needs these two integers. That's the requirement if you're going to use Hedda. Now watch this, Morgan, what if I said, hey, Morgan, what I need you to do is I need you to calculate the sum of two values, but I don't have these values. You need to, I don't know, figure them out, but I just need you to calculate the values of two integers and print it to the screen. That function definition may be a slightly different. Does everybody with me? That may still be a void method, but it may not need anything inside of the parameter list. Is everybody with me? I may not need to pass Morgan anything. Is everybody good with that? So you can have a void. So this is an example of a void method, but a void method that needs two integers passed to it. Okay. All right. So let's keep rocking and rolling. If hopefully thumbs up if that analogy makes sense, because I'm gonna keep going with that analogy. If not, I'll change. I'll switch. I'm good at switching. All right. If we were in class, I would read your faces, and I'll know if you get it or not, and I'll switch it up on the spot. But hey. All right, so here, let's talk about the other type of function or method that exists, which is what we call value returning methods. Value returning methods. Now, value returning methods are very interesting. Let me just show you here. Let's see in my little notes here, I give you several examples, one of each. But here, let's talk about value returning methods. Here's the things that you need to remember, and there are several things here. So a method, so when a method is considered to be, so when a method is called and it returns a value or data. What do I mean by that? An example of that, whether it's an integer or a double or a string, it could be anything or array. It could even be an array. Etc. Okay, when it returns something. So when a method is called or told to execute and it returns a value or data, this method is considered to be a value returning method, is a value returning method. So that's simply what that means. If it returns some value back to you when the method is called. Here are some key things that I want you to remember about a value returning method. Another thing that I want you to remember is this, very important with respect to a value returning method. Value returning methods, we always use this keyword return, okay? This keyword return. So the keyword, and it is a reserved word. The keyword, sorry, I'm all over the place here. Let me slow down with my typing. The keyword return is used and must be used, and it must be. Let's put that there. Must be used to return the value only, to the calling method. So I'll give you an example of that. I promise I will never leave you hanging. We're going to look at an example of what that looks like. But here's the key thing that I want you to appreciate here is that we must use this keyword return. I introduced briefly this idea of the keyword return when we were talking about those statements that are control statements like break and continue. Do you remember that? We talked about those statements, break and continue. Well, return is another is another reserved word or keyword that when it's used, and it needs to be used very thoughtfully, that word return, just like when we use the word break or when we use the word continue, it must be used very thoughtfully. When we place the word return anywhere in a return statement, anywhere in our code, just similar to break, it's going to jump out of that block of code immediately. So here's what I want you to appreciate about this. So the keyword, let's do this. When the keyword, when let's say return statement is executed, control, let's say the computer exits. Let's say the computer exits the current block of code and returns control. And I'm going to say, yeah, let's say this in parentheses, baton back to the method that called it. So let me pause when I say this. So just like the relay race kind of idea, whenever a return statement is encountered, the baton or control is handed back to the method that called that method, okay? The method that called that method. So again, think of the relay race, okay? No one has control unless they have the baton in their hands. And so when that method is executing, all right, as long as that method executes, it has the baton, but when that method encounters or must execute a return statement, then the baton is given back to the method that called that method, okay? So here, another thing that I want you to remember, important, and I will demonstrate this right after I type this. We're gonna look at an example. So here, the return keyword, must be, I'll say that, must be the last statement in the method. Okay, and why is that? Because let me just put a little note here that any code after the return statement will not execute. Okay, that's just like a break statement, just like a continue statement. Any code that you place after the keyword return or that return statement, because it does end in a semicolon, that return statement, it will not execute. Okay, so you've got to place the keyword return in the appropriate place. Let me give you an example. So for instance, let me give you an example of what that syntax looks like, and we're going to talk about it. We'll look at it as a full example in just a second. So here's an example. Let's say, for instance, I have this variable called age. Let's say 25, okay? We'll say for Anthony's sake, we'll say 20, right? All right. Anthony turns 20 in 4 days. So we'll say age equals 20. And then ... There's some more code. There's some more code in this, right? Then what happens if if we wanted to return, let's say Anthony in 5 years from now, right? What if I want to return Anthony's age in 5 years, what Anthony's age will be in 5 years, we could do something like this. Something like that. Is everybody with me? Okay. So, but here's what the thing that I want you to remember here, the syntax. Let's talk about the syntax, and then we're going to apply this as an example. The syntax of when we want to return of a return statement. We must do the following. We must say the following. We must use the keyword return. So return. And then whatever value or attribute, right, that has a value must be after the keyword return. Does everybody see this? So a value, which is a literal value. I'll say that, literal. Something like that, literal value or attribute who has a value it always follows the keyword return. Okay, the keyword return. Is everybody good with this so far? All right. Any questions or concerns so far about the statements that I've made, the concepts that I've introduced so far? All right, so here's what we're going to do if we don't have any questions or concerns. Let's right click really quick. Let's write it some code to demonstrate this. We're going to call this one sum of nums 2. Okay, sum of nums 2. All right, and I'm going to do this again. I wanted just to do a simple example, right? Because the example is not the issue. I want you to see how the concepts work. Okay, and we'll apply these examples, these concepts to other problems. But let's use the example. Let's remind ourselves of the code that we wrote last class period. Okay. We wrote last class period. Okay. So you see that we wrote the sum of nums, and this was an example of a void, right? A void method. So now let's do the following. Let's go ahead and write our main method, if you would, please. There's our main method. Don't forget to comment your closing curly brace. So this is the end of main, and this is the end of the class itself. Please do this because, again, remember, our code is now a lot more complex, and I want us not to get confused. Okay, so definitely make sure that you write your comment, that you document your programs in a thoughtful way. Just moving your faces around so that I can see you just a little clearer. Okay, so here's what we're going to do, you all. What we're going to do is we're going to write a function outside of the main method. I'm not going to worry about main right now. Let's just write our function definition or function declaration. So here, this is our function definition or declaration, right? They mean the same thing, or method definition or method declaration. Either one of those works. For a method called, let's say sum of numbers. We'll say the same thing, sum of numbers. Okay. That needs, let's say we'll say needs 2 integers as well. Okay, for this example. All right. Let's talk about this function. The purpose of this function. Let's say the purpose of this function is to do the following: to calculate the sum of 2 numbers and return the sum to the calling method. That is the purpose of this function. Okay, that is the purpose of this function. And so here, let's talk about the return type. I like to define these things when I'm writing my function definition. We're going to talk about the return type. We're going to talk about the parameter list. What is the parameter? Okay, list. And then we're going to also talk about, then we'll be ready for our function definition. All right, so our parameter, let's start with the return type. Well, the return type of this function, so if I calculate the sum of 2 numbers, 2 integers, let's say 2 integers to be very specific, integers, okay? The sum of 2 integers, to be very specific here. So what is that, what's gonna be the return type? Now, in this example, again, I could have written this several ways. You saw the way we wrote the first program, sum of numbers.java, but here in sum of numbers nums2.java, I am choosing to write it differently. So again, a programmer is an artist. It's how your program may look slightly different than your peer, and you given the same input, you still get the same output. Your program may look differently, and here's an example of where it could look differently, but still get the same output. Yes, Hedda. So what is the return type? It's going to return an integer, absolutely, which is the result of calculating the sum. And so what do you think I'm going to need inside of the parameter list? I'm going to need what? 2 integers, correct? Right? You're going to need those 2 integers. And that's just how I chose to write this method. Okay, so now let's set it up. Let's write the function definition, right? The function definition. What are we starting out with? The modifier. We always start off with the modifier, so public. Now, public is optional. You don't have to say public, but we do have to say static, okay? We definitely have to say static. Public is optional given this example, but static, we do have to say static, because if we don't say static, then the method is what? What would the computer consider this method to be if we don't say the word static? Put it in the chat for me. If we don't specify to the computer that this method is considered to be a static method, what will the computer automatically assume this method to be? There are only two options. A method is either this or that, static or what? Any ideas? A method is either static or instance. Does that make sense, y'all? Instance. And that's very important when we're reading documentation, when we say a method is static, the computer knows what to do. The computer knows that it does not need to create a new object, and that object called this method. That because this method is static, that means the class that's called sum of numbers at 2, it has direct access to this method. Does everybody see the difference here? I know we looked at static versus instance with respect to predefined methods, but this is how we would use static versus instance with respect to user-defined methods. Okay, our methods that we're going to be writing are going to be static for this class, all right, for at least the fundamentals of programming that we're going to learn this semester. But yes, you're going to look in lesson 8 at some examples of like private methods and other things like that. But yes, so that's why we need this method to be considered static, so we don't have to create a new object, and that object I'll call this method. So what always follows the modifier, because the modifier is public and static, is the return type always follows. We used that this method is going to return an integer. Then what always follows the return type is the name of the method. So the name of this method is called sum of numbers. And it must be exact. Then there's open and close parentheses, and then there's open and close curly brace. This is how we set up a method, right? Predefined method. We're not done by no means. And so this is the end of sum of numbers, right? That's the end of sum of numbers. What needs to go inside of the parentheses? Remember, here's where our formal parameter is. Remember the formal parameter? It's associated with the function definition. So what do I need? I need 2 variables, and I need to declare them. So they're data types. That's so important. In the function definition, you must specify the data type. So int, whatever you want to call it, maybe num1 or whatever you want to call it. And then we have another integer that I'm going to pass inside of this method as well. Okay, that I need to pass to this method as well. So this is the shell, the shell of my my function definition. But what do I need now? I need to spell out what I want this function to do. So here, any variable that I need to declare that or use inside of this function, it's considered to be local. And so we're gonna talk about scope today. And so here's what I'm gonna say. I'm gonna put this in here, the scope so these are local variables. Okay. And I'm gonna talk about that in just after we finish this, but just understand when we say scope, I'll talk about what that word scope means in just a second, but understand that these are considered to be local variables only known inside of this method. Okay, only known inside of this method. So think about what variables do you think we may need? Similar to the previous problem, what variables do you think we may need to introduce right now to help me solve this problem? The purpose and the only purpose of this method is to calculate 2 integers. Right? The only responsibility is to calculate 2 integers and get the sum, right? And so let me pause really quickly just so you can get a visual of what I'm talking about right now. So when I used the example with Hedda earlier, I said, Hedda, your role is, I'm going to give you these two integers and I need you just to go off and do your task, right? That was one example. So River, let's say that I'm calling you now, okay? I'm calling you to my office and I'm saying, hey, River, I need you to calculate the sum of these two integers. Here you go. There you are. Okay, there you are, River. And I need you to calculate the sum, and I need that sum back. Okay, I need you to give me that sum back because I need to do something with it. Okay, or something else with it. Is everybody good with that? Does everybody understand that scenario? Okay, so what is River's role? His role is only to calculate the sum and give me that one value back, which is the result. Is everybody with me? So watch what I'm going to do. I'm going to introduce, let's say we introduce a variable called result. That's only known inside of this method. Okay? That means River only knows about result. I don't know about result. Remember, I'm main. I'm the boss, I'm main. I don't know about result. I don't need result. I don't need that variable called result. River needs it because River needs to calculate the sum. So here, watch what River's going to do. River's going to calculate the sum. And River's going to say this. River's going to say result. Just what we're used to doing this in main, but we're now doing it inside of a user-defined method. And it doesn't matter where you do it, whether it's in main or another method. Just these are statements right now should not look foreign to you. What I'm doing right now should not look foreign. It's just where we're doing it may look a little foreign, right? But we've done this code that you see right here inside of the main method. Okay, very good. Oh, no, okay. No, it was just a direct message. I apologize for that. Yes, okay. So is everybody good with this so far? Okay. And so now, what does River need to do in order to give it back to me? River, what do you know? Do you have a clue?
You gotta return it to you.
You gotta return it to me. Return what specifically to me?
The result.
The result, not the result, the variable result or the value result?
The variable result.
No.
Well, it's going to be the value, but you'd
Absolutely.
say return result.
Exactly. Yes, you're right. So exactly. So you're going to return result back to me, right? But guess what? This only returns the value. This statement only returns the value back to the calling method. Does everybody hear what I just said? This does not return the variable. This statement only returns the value that's currently stored in memory for the variable called result. Is everybody good with that? Okay, now let me just say this. I'm going to put this little statement down here below, down here. So after, I'm going to say this, after the return statement, all variables and their values are erased from memory. They no longer exist. Is everybody with me? When the control is given, and I'm going to put this like here, I'm going to put this little statement right here. Also after that, when that return statement executes, control is now given back to the calling method. When I say control, that control just simply means the baton, right? Does everybody hear that? So when the word return is encountered, the value or the variable's value that sits right behind that keyword return is going to be passed or back or given to the calling method. It's going to be passed back. It's going to be passed to or given to the calling method. And the control also goes along with that value. The control is also given back or relinquished back to the method that called it. Is everybody good with that? Okay. So watch. So here I hope that you all, so look, so let me put a little comment here. Give value back to the boss. I'm going to put that in parentheses here. So that's kind of what we're doing here. In that return statement, we're giving the value back to the boss. Does everybody remember that analogy? Okay, so I called River in my office. I said, hey, River, so now let's go back up to Maine and let me now demonstrate what that example of me calling. When I call River to my office, River's name is not River. No, River's name is sum of numbers. Is everybody with me? When I call River, which is sum of numbers, and I give River, those two are sum of numbers, those two values, right? So let's do that. This method will not execute until I call it. Okay, until I call it. Now, watch what I'm going to do. I'm going to do this in steps, and I need you to not that whatever's going on in your environment right now, I need you to just focus on me in this class, okay? Because what I'm going to do right now is going to be out of sequence just a little bit, but there's a method to my madness, okay? So I'm going to call River, and I'm going to say that in quotes, okay? Okay, I'm going to put that in quotes just so you all can see what I'm saying, but I'm going to call the method, all right? The method sum of numbers that needs two integers. That's River. Everybody good with that? So River, I'm going to call you right now, and I'm going to give you the two integers that you need. According to your specification, you need these two integers. So watch. How do we call this method? By its name. And let's say that I give it 30 and 60 just for the sake of it, right? Okay. Now this is how so let me stop and pause right now. If I just leave it like this, okay, watch what I'm doing. If this were to execute just like this, actually just push the run button. Push the run button. Let's see if anything happens. Push the run button really quickly, please. And do you notice that nothing happened? But actually something did happen. It did. But what happened? Let me tell you what happened. So what did happen is, remember who has the baton first or control first? Main method does. So main, what happens is the computer's going to go inside of main, and it realizes there's a call statement right here. It's going to break away. It's going to give the baton or control to the method that has the name sum of numbers that needs two integers. It's going to give that method these two integers. So now it's going to bind. So the computer is going to do what during runtime? It's going to bind or assign the value 30 to the variable num1, and it's going to assign or bind the value 60 to the variable num2, and then those values are going to be used inside of River. All right, as River executes, or as the sum of numbers executes, that function executes. And so what is River going to do? Take 30 and 60 and perform his task, which is what? It's going to create this temporarily, create this variable called result. And I said temporarily, because as long as River is running, this variable called result exists. When River stops executing, this variable called result and num1 and num2 no longer exist. Does everybody hear what I just said? As long as River is performing its task, these are what we call local variables. Num1, num2, and result. These three variables exist. Okay? And so River's going to come here temporarily and create this variable called result. And then he's going to do what? He's going to take the values 30 and 60, add those up to get 90, store that temporarily in memory for the variable called result. And then what is it going to do? Execute this. It's going to then give back 90. So 90 is going to sit right here. 90, the value 90, it is sitting. I'm just going to say it just like that. It's sitting right here. It's sitting, so it's done in real time, but it's going to sit right on top of that call statement. don't do this. Don't type 90 right there. Okay, just follow. Look at the screen. Don't type over that call statement. But 90 is going to sit right on top of the call statement. After the control state, the method executes, it returns a value, and that value sits right on top of the call statement. This is done during runtime, okay? During runtime. So that call statement has a value sitting right on top of it. So what are we going to need to do? We can do several things here, you all. If I don't need, let's say that I, the boss or main, let's say that I need to get that value that River gave me back, that value 90, and I'm going to be responsible for printing it to the screen. Is everybody with me? That I, the boss, I'm the boss, main, I'm going to print the result to the screen, not River, not sum of numbers. So what I could do is I could store that value, what was returned, into a local variable that only I know about, or I could just simply put this in a print statement. If I'm not going to do anything with that value other than print it, I could just put it in, this sum of num and put it in a print statement. It's not out that print statement. What I'm going to do though, I'm going to do this. I'm going to create a variable, a local variable. And this is going to be a variable that I only know about, which is main. I'm going to say maybe, let's call this variable, I could call it, let's say result 2. I'm just going to do this, result 2. No. Let's say this. Let's say some result. Okay, something like that. There's a reason why I didn't call it 2, but because I'm going to use it in just a second. But so everybody see what I just did. So what does this mean? Sum 2. This is only known by main. Okay, the main method. This variable is only known. Why? Because I introduced it in this block of code. So that means the result, this variable called the result, is only known inside of the method called sum of numbers, because it was introduced or declared inside of this block of code. They know nothing about each other. So what I could do is watch this. If I wanted to store this value in memory that was returned from sum of numbers, I could do the following. I could say that sum result equals this. Everybody see what I just did? What am I doing in this one line of code here? This one line of code, I'm storing, I am storing the returned value in a local variable that only main knows about. Right? That only main knows about. So that means, because it's variable. So watch what I could do then. I could main could then later print the result to the screen in a simple statement like this: system.out.print ln, and I can say something like this: the result is, and then concatenate it here with some results. Does this make sense, everyone? So again, let me just summarize it. This particular approach versus what we did last class period. Here, I said, River, hey, come to my office. I need you to perform a task for me. Here are these 2 integers. What did River do? River went back to his office. River calculated the sum of those 2 values, came back to my office and said, here's the result. Is everybody with me? Then which is main, I then got that value from River, and I did whatever I wanted to do with it. Let's say that I wanted to, whatever the sum was given to me back, let's say that I wanted to add 5 to it. Okay, watch what I could do. So I could do anything I wanted to do with it. What if I said something like this? I could do anything I wanted to do with it now because I have the value. I have the value, the result that River gave me back. I can do anything. I could put it and use it in some type of formula, some type of calculation to whatever. that maybe calculate the total or include some taxes or whatever. I don't know, whatever I wanted to do with it. So let's run this program like this. If you would please run the program. And now you see that our program does something, right? What is it doing? So you see the control. So once the computer, so here's what the computer did. The first thing the computer did was declare this local variable called sum result. Then what did the computer do? It went to execute this next line of code in main, but it realized that there was a call statement. So then what did the computer do? The computer searched for a method called sum of numbers that needed 2 integers. It broke outside of main to look for this method. It found this method called sum of numbers that needed 2 integers. Then it went inside this method and executed one statement after another from start to finish. So it created a variable called result, temporary variable called result. It then, the values that were passed to this method, it added those values together to get the value 90. 90 was stored in result. What happened here when the computer executed this return statement? The value 90, not the variable 90, the value 90 was given back to the calling method. And who called this method? Main did. So main got this value back. That value is sitting right here on top. That means 90, the value 90 is sitting right on top of this call statement that you see highlighted. That value then was then stored in this local variable called sum result. I failed to say also that when this return statement executed and the value was given back, all local variables, all variables that were declared temporarily, num1, num2, and result, were destroyed, no longer exist in memory. And then the value was returned back. Does everybody see that? That happens kind of simultaneously. The value 90 was sitting here, and stored temporarily in this local variable that's only known to main. That value is stored in memory for where the variable sum result is referenced. And then what happens? The computer then prints to the screen the result is. It then reference memory, finds the value 90, adds 5 to it, and that is what it's printing to the screen. What is currently stored? If I ask you on a test, you all, if I ask you on a test, put it in the chat for me, please. If I ask you, what is stored in the variable called sum result after the computer executes this code? What value is stored after what value is stored in the variable sum result after this program executes? Not all at once. I need to see some values. If it's right or wrong, we'll fix it. What's currently stored in memory for the variable sum result after this program executes? Okay. All right. So we're saying, I don't see everybody committing here. Maddie, okay. Rod, I see people are Aridonia. I don't see Nick. Where is everybody? I have my faithful few, but I need to see people. I need to see your responding, whether it's right or wrong. Jackson, Max, let's go. Okay. I need everyone to actively participating. All right. So what is the drum roll, please? It is 90. It is 90. Why? Why is 90 still stored in memory? Because I have not updated it. This is the only time. Remember, if you don't use the assignment operator, the equal operator, right? If you don't use the equal operator, then we're not affecting memory. So I did not affect memory here. All I'm doing is doing what? I'm going to memory and fetching the current value that's stored in memory, which is 90, and adding 5 to it just for the sake of printing. But did I modify the value that's stored in some result? Did you see the assignment operator, the equal operator? Do you see me doing anything? Do you see me overwriting the value of some result? No. So the last place I assigned a value to some result was right here. And what is that? That was when I stored 90 in it, in that variable. So guess what? 90 is still stored in that variable. Does everybody see this? Does everybody understand why it's 90 and not 95? I don't want to give you any, I don't want you to give me any points on this next exam, because I may ask you questions like this. Does anybody have any questions or comments or concerns? No? All right, if none, let's keep rocking and rolling. Let's go back to your notes, if you would, please. Here's what I want you to appreciate is I want to talk about, if there are no questions, I want to talk about it. We're going to look at some more examples, I promise. But let's go back to where we left off. We're going to pick up here. Let's go to the fifth idea. The fifth idea that I want to bring to your attention, that you're going to learn about as you read and as you go through the activities in lesson 7, is that you're going to learn about scope. So the scope of variables. You're going to learn about this idea. I've hinted to it, but there are two types of scopes that exist. So first of all, let's talk about what scope is. What is scope? Okay, we're going to talk about that. And so what is scope? The scope of a variable is where that variable is known and can be used. Okay, I like to say the following. I'm going to say this. This little idea. What happens in Vegas stays in Vegas. Has anybody heard of that little idea? What happens in Vegas stays in Vegas? Okay, so that's kind of the idea. I want to look, when we look at the examples here, for instance, in this example, what happens in Vegas stays in Vegas. So here, what happens inside of a block of code stays inside of a block of code. Does everybody hear what I just said? I'm going to put that here below. What happens in a block of code stays in a block of code. And I'm going to say unless. Now, unless what? Right, unless ... Okay, so whatever happens in Vegas stays in Vegas unless. So there is a way to get something out of it. So whatever happens inside of a block of code stays inside of a block of code unless you do the following. Unless we use the return. I'll just say that. We use the return statement. Okay? So whatever happens in Vegas stays in Vegas unless we use the return statement. Okay? The return statement. So any value that you want to use outside of a method, so for instance, right here, any value, like the result, any value that you want to use outside or to be known outside of a block of code, we must return it. So let's say, so for instance, River, you did all that work. You calculate the sum, but guess what? That value 90 that you calculated will stay with you and is only known by you unless you use the keyword return. Does everybody understand that the analogy that I'm, thumbs up if this makes sense, please. That value, all that hard work that River put into calculating the sum. I know it was hard work, right? It was hard work, River, right? Yes, it was hard work. Okay, so all that hard work that River put into calculating the sum, it's just going to stay with River. River's going to be the only person that knows about it unless he returns it, right? So he did it right here. He gave it to me. He gave that value back to me. That is the only way that a value can escape a method, okay? Is only that is known outside of a method. That value, I did not say variable, I said value. So the variable result is destroyed, but the value that was stored in memory can escape this block of code because we use the keyword return. Okay, so let's go back to the definitions here. So when we say scope, there are two types of scopes that exist, right? two types of scope that exist, right? The first type of scope that exists is what we call local, which is what we've seen. So local scope, and then the second type of scope that you may encounter is what we call global scope, global scope. So what in the world is local scope? A local scope is when you have what? It's when you, I'm sorry, just a second. Is when you define what? You define, let's put a little definition here, sorry. Let me see here, moving your faces out. So a local scope was when variables are that are defined, that are declared inside of a method, and can only be used, and I'll say used and known by that method. Okay, so variables that are declared inside of a method and can only be used and known and are only known by that method and are only known by that method. Okay, so it's declared inside of a method, meaning a block of code, and it can only be used inside that block of code, and it's only known by that block of code or by that method. Then what in the world? So here, let me just say this also about a local variable, you all, that here, local variables, let's say that local variables, not let's get rid of that. Local variables are destroyed in memory, meaning erased, after that block of code executes. Right? It's no longer known. So that's whatever happens in Vegas stays in Vegas. That's this idea that when that block of code, after it executes and passes control back to whoever called that method, that all local variables are destroyed. So when we say local scope, so what in the world is global scope? You're going to learn about that in your reading. So these are variables that are declared outside of a method, but inside of the class. That's very important. So it's inside of the method. It's inside of the class, but it's not declared inside of a variable, of a method. You're going to see examples of that. So this method, let's say here, this type of method. So this type of method can be used or accessed by all methods within the class. So it can be used and by all of the methods inside of a class. Okay, all of the methods inside of a class. You're going to see several examples of that going forward. So you will see in your reading, you're going to see several examples of what we mean by global scope versus local scope. Let me pay attention to the time here. All right, so here's what I want us to do. We've gotten through most of the things that I wanted for us to discuss today, but what I do want to, and I want to go back to what I began the discussion with to the beginning of class. I mentioned that on Tuesday's class, here's what I want us to do. I want us to, we're going to have office hours, instructor office hours. So I will make myself available during our class time. I will also make available tutorial videos on lesson 7. So to give you some additional instruction, some additional guidance, and introduce some other example, give you some more examples, as well as introduce a few more concepts like signature of a method and things of that nature in a tutorial video. Okay, I'll post that tutorial video. I'll post it before next week, so that if you want to just knock it out and look at the video and read as you're completing the activities for lesson 7, that tutorial video will be available. But we do not have a physical class on Tuesday, but I will be available during this time virtually. And I'll be available for any questions that you may have, whether it's class related or not, grades or whatever. If you need a tutorial or examples, I'll be glad to do anything that you need me to do during that time. You all have an awesome Thanksgiving. I do have a class reflection for today. 4 simple questions. 6 simple questions that I want you to answer, and I'm going to let you go right now. Here is the code that you need. Have an awesome Thanksgiving break. What am I saying? Christmas. Good grief. Thanksgiving break, and eat a lot of turkey or dressing, or just simply binge watch some Netflix, whatever it is to relax your mind, but also do some work. Please schedule some time to get caught up in your various classes, not just mine. Here's the code that you need for today. I'll put it in the chat there. And you're free to go. You have an awesome Thanksgiving. All right, if I don't see you, but if you do have questions or concerns, don't hesitate to stop by during office hours on Tuesday. And I will see you the following week. Be safe, right? Be safe, and I look forward to seeing you after the Thanksgiving break. Take care, everybody. I hope you learned something today. All right, something today. Take care.